Hello all, welcome to our course on reinforced concrete structures. We are in our next chapter called slabs. I hope I have to dictate from initial. We have so far seen limit state of collapse, limit state of serviceability. Under limit state of collapse, we have seen how to design a single reinforced beam, double reinforced beam, flange beams, and also we have how to design for a shear, how to design for a torsion, etc., etc. Okay, and I think we have from the previous thing we have covered uh, up to 50 problems. I think so. Okay, so if you have noted down the question and answer, I hope in your notes you should have at least 50 problems of RCC covering overall syllabus. Okay, so this is one of the peculiar topic in RCC design, because slabs are nothing but a beam. We are going to design again. See, in a structural engineering there is nothing but a tension and compression. There is a bending, there is a axial forces, there is a shear, there is a torsion. Slab, obviously, how the load will transfer. If you are sitting in a chair, you are sitting, obviously the chair will be placed over a slab, so the slab will bend. Obviously the slab will bend, the load will be transferred to the beam. Okay, so the procedure of transferring the load is nothing but a bending again. So it is obviously, when you are transferring the load, the slab is transferring the load where we have bending action. The bending action transfers to the beam, beam to the column, column to the footing, footing to the ground. Okay, so slab is nothing but a beam. That's much you should know by now. Okay, so I have shown a picture here. It is nothing but, you can decide there are two types of slabs are there. Here if you see, they have cranked the slab, cranked bar. Okay, and one more thing I wish to tell you. So how, what you are going to provide is nothing but a reinforcement again, correct? So designing a slab, most of the cases slab will be 100 mm to 150 mm thick for all the residency, for every cases. Okay, if you are going for port and harbor structures, maybe 400 500 mm thickness will be there for a port. So the thickness, and so we are going to design a slab similar to the beam with the width 1 meter, width of the slab per meter. Okay, we will design per meter of slab is nothing but a beam of width per meter and depth very less, not up to beam have, we have seen a beam of depth 300 400 500 1 meter and all, right? So the slab width will be, depth will be maximum up to 150 mm to 200 mm. Okay, so we'll go inside this. I hope I am very sure, and from the picture what you are seeing so far, I may be boring you, but this is the reinforcement, this is what we are going to see in the slab. Okay, so if you see, so the classification, next topic is classification. Obviously you have listened so far. If you are semester still a college student or anything, you would have studied the two names, one way slab and two way slab. So this is the figure for one way slab and two way slab. So most of the cases, one way slab is nothing but a rectangular slab. For if you see the ratio, lx by ly is greater than 2 is nothing but, so longer direction, consider the longer direction is x direction. So it will be greater than 2 times of the ly, which is nothing but, if you say if you take a slab of 1 meter of one dimension, another dimension will be more than 2 meter. So consider 5 meter cross 1 meter rectangle. I hope you can imagine 5 meter cross 1 meter rectangle will be a one way slab. Okay, and you can see the figure, next figure is nothing but how the load is being transferred. Load is being transferred by bending action as usual, but the in the longer direction. Okay, in the longer direction, you see the lx, I told you lx is the longer direction, like 5 meter 6 meter 7 meter. Okay, but ly direction is very small. So the load, the bending action, bending will be transferred to the beam on the lx and lx direction beam. Okay, it won't be transferred to ly direction. That is called one way slab. So what is two way slab? Obviously opposite to that. So length lx by ly will be lesser than or equal to 2. It is not 1. Okay, always if you see somewhere, if you are sitting in a house or somewhere, you see your room will be mostly 16 cross 10 feet, correct? 16 cross 10 or 10. If your kitchen will be 10 cross 10, hall will be 16 cross 16. So most of the cases, your every room is almost two way slab, right? You see the ratio, the ratio will fall under lxy by ly will be lesser than or equal to 2. So most of the cases everywhere will put two way slab. So the load will be transferred in all the beams. You can see lx direction also, ly direction. So this is a major classification, one way slab and two way slab. I hope I made you clear. Most of the case, if you see a rectangle, big rectangle, not like exact rectangle, bigger rectangle, like more than 2 times of the ratio, so that rectangle will be one way slab. If most of the case, if you see almost a square, it will be a two way slab. Okay, so this is general people's definition. As a structural engineer, what else you should know is, when you are applying a load over the slab, considering it as a beam, this is derived from Westergaard theory. Okay, and what I'm telling you the conclusion, I'm not going to tell you the theory, I'm giving you a conclusion. What he concluded is, the bending moment transferred for one way slab in LX direction will be very considered it is 100. Okay, 100 kilonewton meter. No, slab will not transfer up to that much, 20 or 30 kilonewton per meter. Okay, consider a slab which have a moment of 30 kilonewton meter in one direction, then opposite direction, in LY direction it will be less than 3 to 1, something like that. Okay, only 1 kilonewton per meter. In that case, you understood, right, the ratio. In longer direction 30 number, you see the number 30, but in shorter direction it is 1 2 3 something, very small number. So this is how the bending moment, this is called one way slab. Okay, one way slab is nothing but the bending moment will be very high in longer direction, it will be very minimum in the shorter direction. That is called one way slab. Similarly, in two way slab, opposite. Okay, so the bending in both direction will be almost 50%. Like if it is 30 in one side, 15, 20 or 10 in opposite, you cannot neglect it, right? When 10 kilonewton is very big number compared to 1, so you cannot neglect that. That is for two way slab. Okay, if somebody asks you in interview anywhere, like if you are going for gate interview or exam interview or SSC interview, railways interview, if somebody asks you what is the difference between one way slab and two way slab, don't tell, just tell the ratio. You have to tell the this difference also. Okay, the bending moment, how the bending moment is maximum for one way slab, how it is minimum for shorter direction, and two way slab both the bending moment should be considerable amount, so we have to put reinforcement in both the direction. Okay, remember this point. So I have shown some reinforcement. This is what we are going to design. Okay, mostly we won't design this since it is a exam oriented course. We want nobody is going to ask you for like a semester this one. So anyhow, this what I'm showing you, this figure is your conclusion at the end of this chapter, or at the end of the topic. Okay, somebody asks you slab, you should remember this one. Okay, one way slab, you see there is a reinforcement on one direction and distribution steel on other direction. Okay, this is what you can zoom and pass and see. This is called one way slab. As I told you, one way slab is a rectangular slab, longer direction they have many bars, since the bending moment transfer is very high. And shorter direction, you see the shorter direction they have provided only 4 or 5 bars. Okay, so this is the conclusion. So if somebody asks you slab design means, you are going to tell the width and depth, or obviously the depth is fixed for most of the cases. Width is based on what? Based on the building plan, right? So width is already known, you have to cover the total building, so width is known. So and depth is mostly 100 150, that is standard. Okay, if you are going for top floor, second floor, third floor, then there will be big difference, we can go up to 175 to 200. So width and depth is constant. So slab design is nothing but you have to tell the bar, and even the bar is constant, you can note somewhere. So even everything is known, nobody is going to ask you, the only maybe an interview they may ask you. So the slab is overall slab for the room dimension, depth is 100 150 175 200 if based on the load coming above, only this much thickness will be there. And the reinforcement most of the cases 8 mm or 10 mm, and spacing will be most of the cases 100 mm center to center, 200 mm center to no 200 100 125 in that case. Okay, I hope don't get confused. I have told you the answer. Slab means this is your answer. Whatever the question they ask, this is your answer. Okay. So in this one-way slab, there will be a distribution steel on one side and main bars on the other side. Because why we need distribution steel? Obviously, you cannot have leave a concrete without reinforcement for long direction, right? For that purpose, and we have to put some minimum reinforcement of the steel in one dimension. Okay, to avoid shrinkage, crack, everything. Okay, so we have distribution steel on one direction, but the main bars in one direction to transfer the bending moment. Okay, so two-way slab. This is a two-way slab. Okay, so two-way slab is almost like a square slab. As I told you, the reinforcement, the load has to be transferred to the both the direction beams. I hope you understood beam. Beam is the boundary of the slab. Okay, the slab will be resting on the beam. So the load has to be transferred to the beam. Okay, in two-way slab, two direction reinforcement are provided. In two-way slab, there are two types are there: simply supported, restrained slab. Okay, so what is simply supported? You are just placing the slab over a simply you are supporting over the 4 columns, or like it is a bridge. Okay, bridge most of the case it is simply supported, or like a restrained slab. In your apartment, when you are sitting in a house or building, you can see above all the slabs are interlocked at the end with the column and beam, correct? So in that case it is restrained on 4 corners. Okay, so there are two types. Two-way slabs are two types: simply supported and restrained condition. Okay, restrained slab. If it is simply supported, it is very simple. So you take a A4 sheet paper. Okay, assume it is a two-way slab. When you are pressing your finger at the center, what will happen? 4 corners will lift and A4 sheet will go down, right? So it is simply supported. Okay, so there is a torsion acting on 4 corners. Nobody is arresting that, so it is freely lifting and the paper is going down. Okay, consider, take the same, that is simply supported condition. Okay, take the same A4 sheet, ask somebody to hold the four corners. Now you press it, the paper is not going down because it is restrained in four corners. So the people who are holding at the corners will feel the torsion experienced. Okay, so in the restrained condition you have to put extra reinforcement at the corners. That is, in the figure you are seeing that yellow color bars, that is nothing but a torsional bars provided at the support at the corners, so that it won't experience a torsion. So for extra torsion which is about to come when it is restrained condition, we have to put that extra reinforcement. Okay, we'll see little more detail in coming this thing. I hope I made you clear what is two-way slab, what are the types of two-way slab, and what is the reinforcement will look like. Okay, I think I have given you an answer here. You can see the slab dimension they have given here: 1.8 meter cross 1.8 meters, a square slab and 100 thick slab, and they have given a reinforcement conditions also. And one more thing I forgot to tell, when you are designing a two-way slab in restrained condition, you will divide the slab into edges, middle strip, and edges again. Both in x and y direction there will be edges. Okay, so in x direction first comes edge, middle, edge. In y direction edge, middle, edge. Okay, so only in the mid span you will put the main reinforcement. In edge strip you will put only the minimum reinforcement. Okay, okay. So you can pause and rewind and here, but don't worry. What are the information going to come in coming slides, I have told you before. So if you didn't understand anything, no problem, you will learn in coming slides. Okay, so at the end of this slide what I have told you, what is two-way slab, what are the types of two-way slab. Okay, and what is the extra reinforcement, what is torsional reinforcement, and what is the middle strip, everything. Okay, you can pause and zoom the figure and you can try to understand how the reinforcement are provided. This picture is very clear, this is your answer. If somebody asks you to, in your maybe as a civil engineer you have to design your own building, somebody asks you to design a two-way slab, just take the input of load and then you have to give this as a final answer to them. Okay, the slide which you are seeing now. Okay, so next so next one is notable points you should know. The minimum steel required to avoid a sudden failure. Okay, why we need to provide minimum steel is to avoid sudden failure, because without any minimum steel, the concrete is brittle and it will fail, collapse. Okay, that you know. So and maximum spacing. You cannot have the reinforcement 400 mm, 500 mm distance, right? One bar is here. You cannot have the next bar at 500 mm away from you, because then there will be more concrete, which is easy to crack. And the longer direction is should be next notable point you should know is longer direction. If it is ly, the longer direction should always support over a strong beam. Shorter direction, I told you, if it is a one way slab, shorter direction moment will be very less, so you can support over a small beam or no beam at all. Okay, no beam at all, you can just use it as a very short span. Okay, you can directly put a like a flat slab or something, directly rest over the column. Okay, so okay, coming to the next topic is I told you types of two-way slabs. So there are two types. One case is simply supported. Example bridge I told you. So you see the formula. What is the formula to calculate bending moment? Now it is two-way slab. Okay, remember it is two-way slab. So the bending moment will be very high in both the directions. So mx is alpha WLX square, alpha WLX square. Both are LX only. Don't get confused. Mx also LX, MYL also LX. You can go through any textbooks how it is derived. It's very very simple derivation. Okay, how they derived is taking the slab and then putting that UDL load over the slab, equating the WL square by 8, WL square by 8, cancelling everything, they got these coefficients. Okay, it's very simple, you can take any standard textbook, but no need at all. So you know bending moment is load into distance. From there only this formula has been derived. Okay, you have to memorize this if you don't want to see the textbook, but this is very simple, right? So to calculate the bending moment, mx alpha x WLX square, my alpha y WLY square. Okay, LX square. Okay, so what is that alpha x and alpha y is nothing but a bending moment coefficient based on your span length. Okay, span length ratio, based on the span length ratio, alpha x and alpha y. So for different span length ratio, this table I have taken from IS 456. Okay, in annexure. Okay, annexure design for a slab, I have taken this slab. This table is for bending moment coefficient for simply supported and four sides. Okay, based on the span length ratio, ly by lx, that ratio, if your ratio is 1 exactly, square means alpha x and alpha value is 0.062, 0.0062. Okay, so for different span length ratio, they have given the alpha x and alpha y value. So put that alpha x and alpha y value here, put the load, put the length, then you know the bending moment which is going to come on your slab. That's it. Okay, so there is no formula. I hope you know already how to, if you know the bending moment, how to design a reinforcement. 0.87 FIAST, same story. Okay, throughout same story, or you know how to calculate, right? If you are if you know the bending moment, then everything same procedure you should follow as a beam. So calculating bending moment is little different here, that's it. You have to use this coefficient. So this coefficient you no need to memorize, they will give in the question. Okay, but anyway, you should know how this, what is the alpha x and alpha y, that's it. Okay, so going to the next type, is a type of two-way slab. Is next type is restrained slab. I told you, right? Second type is restrained. I am restraining the four corners. So if you see, this is based on Johnson yield line theory. Exactly same alpha x and alpha y. Here this alpha and alpha x y is based on beta x and beta y. This is taken from I will tell you little later. So the coefficients are little different, but they will give you in the question. Don't worry. Okay. So because the coefficients are concerned, because four side are considered as a fixed beam and or continuous beam. Okay. If there is a continuous beam, so if continuous slab, the slab will be continuous. So there will be support in between, right? What do you mean by continuous? You consider there is a three support. So center support, it is crossing. The slab is crossing center support. So there will be a hogging, sagging, hogging. So there will be negative bending moment may arise. Okay, so the coefficients are little bit different. So they have given an IS456 again in the table, so you should verify that table to get the coefficients, and then we have to use the same formula, exactly same formula there, but the coefficients are different for the case of restrained or continuous. Okay, continuous slabs. So this, and I told you extra thing which will come here other than simply supported here is you have to put a torsion reinforcement. Torsion reinforcement area is nothing but 0.75 of ASTX. ASTX nothing but your, what is the AST reinforcement area, total area considered like 700 mm square, 500 mm square, that much area. How much you are going to get as an answer, you have to provide in the torsional area in layers, like 100 mm 100. Consider it's like if your requirement of torsional reinforcement, consider your ASTX is 100. Okay, 100, then you have to provide 75 mm square, right? In 80 you cannot provide 75. uh, I hope you understood. 75 will be very, because total slab itself, if you are going to provide mid strip, you are going to provide 100 means 75 is very difficult to provide, so you will provide in layers. Okay, base layer, front layer, top layer, like that. Okay, so you can zoom and note the coefficient they have given, how much length you should provide the torsion reinforcement. So at least you should provide 0.2 lx, 0.2 times of the length of the slab you should provide, and how much you should provide is 0.875 into ASTX, that you should provide. Okay, so this is the difference I told you. Middle strip in ly direction, if it is for span this direction, there will be a middle strip. So there will be middle strip and edge strip in both the directions, and the dimension is ly by 8, ly by 8. Middle strip will be 3 by 4 of ly in both the directions. Okay, yeah. So 1 by 8, 1 by 8 you will take it for edges, and in between you will take it as a 3 by 4. Okay, so you will design the reinforcement for the mid strip. For edge you will put only the minimum reinforcement. Okay, so this is the two-way slab. I hope I made you very clear. This is a two-way slab. This is how you should design. Two-way slab, restrained slab, this is how you should design. Okay, so this classification also you should know. Again I told you, right? Already I told you, two-way restrained slab is same formula, alpha x and alpha y, almost same formula. Here instead of their beta things will come, that you can refer in table 26 in IS 456. Most of the cases they will provide you the coefficient, you just put multiply, you will get the bending moments. Okay, so I made you, furthermore you can zoom and pass and see the torsional reinforcement. As I already told you, there will be, you have to provide the torsional reinforcement in all the corners. If it is continuous, you have to provide a continuous slab, you have to provide like a second figure in between. Top and continuous supports that side and this side, you have to provide the reinforcement. Okay, but you no need to provide 0.75. You have to provide half of the 0.75 that side, half of the 0.75 this side. Okay, so you can see and you can pass. This is the minimum requirement, and the 0.2 lx is 0.2 times of the length, like 20% of the length you should provide. There is constant. 20% of the length of the slab you should provide a torsional reinforcement is a constant, and you have to provide 0.75 of AST is also a constant. Okay, the right side third figure I have given you some with the dimensions. This will be your final answer for your restrained slab. Okay, if somebody is asking you to, it's like apartment, your own building. Okay, so if it is somebody is asking you to design your slab for your home, this is the final answer you should get. How, where you should crank, and what are the torsional reinforcement you should provide, what is the length, and what is 0.2 lx, everything. Okay, so under the blue color, this is what most of the case it will be the same, 8 mm diameter and 250 mm center to center on all the edges, and 8 mm diameter bar with less spacing, right? If it is a mid strip, more bending moment will be there. Okay, so 8 mm dia bar at 160 mm center to center they have provided in one direction, 210 mm in other direction. That's what they have provided. It's very simple. So three details they will be asking you. What is the main bar? What is the diameter? Mostly everything is 8. So take out that one. So how much spacing you should provide in longer direction? How much spacing provide in shorter direction? How much spacing you should provide in edge strip? And what is the torsional reinforcement length? Okay. So they will make it as a mesh and they will keep it there. Okay. So another 1 marks, whatever possible 1 marks raise. What is the maximum size of coarse aggregate you can use is depth of the slabs divided by 4. What is the maximum size of the steel bar you should use is D by 8. Okay, depth of the slab is 100 mm mostly, 100 by 8. Maximum size you can use should be lesser than or equal to 100. Okay, so isotropic slabs means square slab or circular slab. In that case, x and y direction will be same. Orthotropic slab is nothing but rectangular slab or continuous slab. So I have shown one figure at the side, you can pause and zoom it. It is nothing but a flat slab. Means the slab is directly resting over the column. Okay, there is no beam at all. That is called flat slab. That is it's a revolution in design nowadays, because there is no, we are not providing any beam, so that we are saving huge economy because of and there is no congestion, easy to construction. So it is quick and economical, that flat slabs are. And maximum dia shall not exceed, I have mentioned minimum percentage of steel you should provide is, if you are using a mild steel bar, nowhere we will use 0.15 percentage of the gross area. Mostly this you should know, minimum percentage of the steel for HYSD bars we will use 0.12 percentage of the gross area. Okay, and I told you initially why we are providing the crank. So whenever the crank, I hope you understood, they're like a bend up bars. Okay, so why we are providing at the crank at the supports, and we will provide alternative bars. You can see the figure, one bar is cranked, one bar is rest, one bar is cranked, one bar is at rest, going straight. So we are providing alternate because when the bars are provided minimum spacing, you no need to crank everything. Like why we are cranking, first we should know why we are cranking is to resist the negative bending moment of the support. I told you, since it is a fixed beam, if you remember fixed beam in structural analysis, there will be a negative bending moment coming at the supports. So to arrest the negative bending moment, you need you cannot provide the sagging reinforcement, right? Because slab sagging at the mid strip is okay, because you have to provide the tension at the bottom, so you will provide the reinforcement at the bottom. At the when the slab is coming towards the beam, there will be a negative bending moment, so you have to provide the reinforcement at the top also. So this that is why we are doing the crank, okay, at the supports. And you can see the remaining thing, there will be a heavy shear force coming at the supports, which is not there anywhere in the slab. You won't even design for a shear, with shear will be very very minimum. So anyhow at the support, you there will be a heavy shear, so we are having that crank. Okay, so I think I have answered the remaining thing. You can see, I think I have answered that. How will you design for one way slab? First thing, you will determine the effective or total depth of the slab using MU limit formula. Okay, I hope you know what is MU limit formula. First assume something. Okay, assume the depth. If you don't know depth, assume something 100, 125, and using MU limit formula determine it, and verify whether that depth is okay or not. Okay, that's what step one. You should know determining the effective or total depth based on bending. Second, put that slab for shear force. Most of the case shear will pass. Okay, shear force which is coming will be very less, so shear will pass. So check the depth of slab is okay or not. Then if everything is okay, put the depth and determine the AST value. Okay, determine the area of steel value. So the area of steel, if I get like 400 mm square, then it is very easy, 8 mm at 100 mm center to center, 150 mm center to center, that's it. Okay, and then determine the AST, determine the diameter of and spacing of the reinforcing bars. That's it. That's another one way slab. Okay, so everything is same exactly how you did in your beam, only how will you determine the bending moment is the difference. Okay, so next thing is design of two-way slab. Design of two-way slab, I have given 8 steps. You can pass and note down. First thing is, this case I have given for simply supported. Okay, first step one, you will assume the thickness. First you should assume the thickness, means the depth. Okay, assume the thickness and effective depth. From IS 456, as I told you, you get the coefficient. If you know the depth only, you can go proceed next step. So assume that and get the mx and mo value what is about expected. Then using the bending moment formula, bending moment determined, mu limit. Okay, I will tell you. Step 2 is you are getting the bending moment like 100 or 50 or something. If you already know the formula, I think you remember mu limit formula 0.138 FCK BD square. Do you remember Fe 250, Fe 415, something like that? Okay, so using that formula, what you studied in singly reinforced MU limit formula, use that value to determine the depth. Check the depth is okay or not, what you assumed. If everything is okay, proceed to step 4, or else change the depth, come step 1, step 2, step 3 again. Okay, again I'm repeating: step 1, assume some depth; step 2, go there and determine your mx and my for the given case, the alpha x, that formula using that. Come to step 3, use that when you know m equal to 0.138 fck bd square, correct? So you know m from step 2, you know d and b from step 1. Okay, b mostly 1 meter. So from that, sorry, from step 3, you determine the depth required. Okay, so you compare the depth assumed is okay or not. Then if it is okay, check for that step 3 is over. Okay, the slab is ready. Then for that particular bending moment, you design the ast limit. Okay, step 5, you determine the ast in short span and long span. So step 6 is check whether minimum and maximum AST condition it is satisfying or not. Minimum reinforcement, I hope you know what you should provide, that it is satisfying or not. Step 7, check it for whether the shear force and development length at short edge is okay. Step 8, check for shear force and development the long edge is okay. Okay, if you follow these 8 steps, the design of simply supported slab is over. Okay, so I hope we are not like I couldn't explain the full with the problem, but this is the procedure. If you know this 8 step, I hope you can easily follow up. But you cannot expect some railway board or any type of exams. You cannot expect they will ask you to solve the full problem. Okay, so if you are having a restrained slab, there will be some extra steps will come, right? Because we are dividing into middle strip and edge strips, and we are have to provide the torsional reinforcement, right? So you can pause the video and note down. This is what the extra steps you will follow. Okay, so that's it. I'll show one problem. Like they have given a square slab. I hope from up to this I should conclude. So what is the major difference here? There is no major difference at all. If you know beam, how to design for a beam, how to design for a shear in the beam, everything is same. No new formulas came, only calculating the bending moment values using the coefficient is the difference. That's it. Okay, so they have given one problem here, simple problem. Yeah, square slab of 4 meter cross 4 meter is a simply supported slab. Okay, square slab they have given. If it is subject to a design load of 12 kPa, they have given the load. The moment capacity as per IS 456, use they have given a coefficient also. Okay, so the everything is given. So what is the answer? You know the formula, mx equal to alpha x WLX square, alpha y WLX square. So load is given W kPa, Lx and Ly they have given 4 meter. So just multiply alpha x WLX square, both are same since it is a square slab. So answer is 11.9 kilonewton meter. You see, I hope you to memorize this number. See the bending moment only 11. In beam for singly reinforced, you have seen a bending moment of 60, 70, 80, 90. Double you have seen 150, 200, 250 and all. Flange rate reached 250, 270, 280, correct? You should understand slab bending moment, you see the value when you are solving some problem, whether you are solving in a semester, whether you are solving in any exams. If you are getting an answer 100, no, your slab cannot be having 100, obviously. Okay, slab answer should be in the range of 10, 20, maximum 30 itself, very big number. Okay, so have that in mind. So design a two-way slab for a room of this question. I have a PDF attached as a solution in different, I hope I taken from different source. So I have an answer for that. If you need, you can ask me in a doubt clearing session, or I can upload the answer, or along with this one I will give the document answer for this one. Okay, so if you try to understand this answer, this question, total slab design will be over. Because you see the question, they are asking to design a two-way slab for a room of 5.5 meter into 4 meter, and the superimposed load is 5 kilonewton per meter. They have used M15, Fe4 and 5. And first case is simply supported. Second case, both second case is also simply supported, but restrained. Okay, restrained condition. So if you know, this is the final slide. If you know how to design for this one, then your total this thing will be over. I will try to see. Okay, so you can see this is a PDF for the answer for that previous question. You can pause from and you can pause and see. Give me a second. So it starts from here. So design a two-way slab. This is the exact question I asked. Okay, so I think I have given you a step-by-step procedure, right? I follow the same procedure. If corners are not held down, so they are first assuming the thickness. I told you, right? Step 1 is assuming the thickness of the slab and effective depth. Okay, so then I will know the Ly by Lx ratio. This they have calculated Ly by Lx ratio. So they are assuming, okay, it is a two-way slab. Okay, step 2, they are using that mx and my formula, alpha x w l x square, that formula, getting the coefficients from the is 456, put that coefficients there, they are also calculating the load. Okay, so dead load of the slab, you know the self weight, right? Multiply live load they have given, add all the loads, multiply by 1.5 factor, you will get the load or the w. Okay, so they are calculating the bending moment. Alpha value is given, w value the calculated, length you have assumed, right? Length is given here, span length is given. Okay, so adding everything, you will get the bending moment value. You know the formula for bending moment is, step 3 is 0.138 fck bd square. You know everything, put the d one side, bring everything other side, you are getting depth 100 mm. Okay, so whatever we assumed here, 140 mm, we no need to proceed with this one, so 100 mm is enough. So putting that 100 mm and overall depth 120 mm, we are going to provide the reinforcement. The same formula, I hope you know this formula, 0.87 fi ast into, this is for ast limit they have given here. Okay, so and then they have checked shear force, and then they have checked the development length. There is a one case, edges are not simply supported. I will attach the pdf, don't worry, I will attach the pdf along with this video, so you can see this answer for the previous question. If you try to understand line by line, that's it. Nobody can beat you in slab. Okay, so what is the difference will be in this corners not held down is nothing but they will have a torsion reinforcement you have to design, that's it. Procedure will be same, taking coefficient will be same, they will have a extra torsional reinforcement here. You can see they have provided a midstream reinforcement, and in edges they have provided a minimum reinforcement. Okay, so if you have any doubt, you can ask me. Corner reinforcement, nothing but torsion reinforcement, you can see how they have provided. So this will be your final answer. So they have provided 8 mm dia bars, 100 mm center to center in one direction, 8 mm dia bars, 140 mm center to center in other direction, and they have provided torsional reinforcement of 8 mm at 70 center to center, and they have given a strip length, everything. Okay, so with this I will conclude the video. uh, I hope now you know what, at least you can answer these questions, right? What is slab, and what are the types of slab, and how to design a slab. Okay, at least little bit. And the fourth thing, how, what is the major difference between beam and slab. Okay, so how to solve a problem in the slab. Okay, if you know this problem, try to solve this problem and try to understand line by line, so that you, nobody can beat you. But this is purely semester oriented, or like a pure, if you are going for a job real time site, this one. If for exam point of view, I don't think they will ask more about designing a slab. Okay, mostly they will stay with the coefficients. They cannot most maximum they can ask 1 mark or 2 mark, right? They cannot ask you to design a full slab. They won't ask you to check for a shear. We have solved some problems in slab deflection in limit state of serviceability chapter, that they may ask. Limit state of serviceability is deflection for slab. Else nothing there else to ask. Only I showed you one exam, right? Maximum they will stay there, or they will ask for definitions on those stories. Okay, but anyhow, if you try to understand this problem, over maximum they can ask only this much. Okay, so try to understand this problem. With that, we will close this topic. Thank you, we'll see you in next topic.